All right, so in this video note, we are going to talk about how you can calculate work and power with someone in motion. And so what I need, or what you should do, is go and print out the Google Doc for these notes, or open and make a copy of the Google Doc and type your information as you watch this video. Okay, so first of all, let's define work. Work is any force on an object that causes it to move in a certain distance. So we have a mathematical formula for that. So work equals force times distance. And so we use the unit joule with a J. And something to note about that is that time does not affect the amount of work done on an object. Now, power is the rate at which work is done. So you have to use the work unit and time to find out how much power there is. And so power equals work divided by time. And we use watt, and we use a W for watt when we're calculating power. So one thing I want to know is that if there is no movement, then no work is done. Right? So if you look at this picture, you have this person here pushing on this 300 kilogram ball, and he's pushing on it with a certain amount of force, but it's not going anywhere. There's no distance, so the work is 0. Over here in this scenario, you have a person with a smaller ball with 100 kilograms of mass, and it's putting a certain amount of force on it, and it's moving 6 meters. It went 6 meters. So there is work done on this person. This person has done work because it's not 0 and it has moved. There's distance. So we're going to do some practice problems in your notes. Okay, we're going to do these step by step. So number 1 says a world-class 90 kilogram sprinter has an acceleration of 12 meters per second squared during his run. Well, we have a mass number and we have an acceleration number. We don't have force, so we first have to calculate force. Now, we learned about force in the last unit, but force equals mass times acceleration. So our mass number is going to be a kilograms number, so that's going to be 90, and then our acceleration number will have that meters per second squared, so that would be 12. So 90 times 12 is going to give you your force number, which is 1,080, and remember it's newtons. Newtons, we learned that last unit. Okay, so now that we have a force number, based off of your force calculation, determine the amount of work done if the runner runs a distance of 500 meters. So we have so remember, our work formula is force times distance. So we just found our force number from the previous question, and then it says in the problem, it says a distance of 500 meters. So now we have both of our numbers, so we can plug them into the formula. So force is 1,080 newtons times the distance, which is 500 meters. And if you put that in your calculator, that should be your work, 540,000 joules. Don't forget the J for the unit for work. All right, so now it says if they do this in 130 seconds, what is the power output of the sprinter? So how much power is the sprinter exerting? And so we have to remember the formula, power equals work divided by time. So the work number, again, was determined in the previous question. So there's our work, and then the time is in the question, 130 seconds. So you take your work number, which is 540,000 joules, and divide it by the time, which is 130 seconds. And if you put that into your calculator, you should get 4,153.8 watts. And don't forget the W. All right, so then it says if they do it then in 92 seconds, what is the power output of the sprinter? So again, power equals work divided by time. So our work number, again, is the same from problem B. It's 540,000 joules. And then our time number would be 92 seconds for this situation. So 540,000 joules divided by 92 seconds. You put that in a calculator and you should get 5,869.6 watts. So which situation would have more power? You just look at your numbers, and the one that had more power would be the one who did the work in less time, in 92 seconds. All right, so let's go on to question 2. What I want you to try to do is pause the video and see if you can answer A and B and C before I review it. All right, so number 2 says, a box is moved with a force of 20 newtons. How much work is done on a box if it moves 25 meters? So we are looking for work. So remember, work equals force times distance. And so the newtons number will tell you that that's the force. It says with a force of. So our force number is 20, and our distance has the unit of meters, so that helps us remember that it's distance times 25. So you put that in a calculator and you should have gotten 500 joules. So then it says, if they do this in 2 minutes, okay, what is the power output of the person? So this is 2 minutes. We need to convert 2 seconds. So we have to go back to our conversion that we used back in our previous unit. So remember, we have to use that dimensional analysis process. So 2 minutes. So how many seconds are in 1 minute? Well, there's 60 seconds in a minute. So you put the 60 on top and the minute on the bottom. So you can cross off minutes, and now you have seconds left. So you just take 2 times 60, and that's how many seconds is in 2 minutes. So that's 120 seconds. Okay, so now that we have converted into seconds, we can now do our problem. So we were trying to find power. So power equals work divided by time. So we are going to use our work number we found in the previous problem. So 500 joules is 500 joules was from the work from the previous problem, and then our time, which we changed it and converted it to 120 seconds. So we divide that, and you should get 4.2 watts. Don't forget the W. All right, so then it says, if they can do this in 45 seconds, what is the power of the output of this person? So all we're doing is changing the time. So we're still using that same work number. So power equals work divided by time. So we're using the 500 joules, and we're dividing it by this new number, 45 seconds, as this new problem is asking. And your answer should be 11.1 watts. Okay, now before continuing with 3 and 4, by watching me, please pause the video and try to do them on your own. All right, so question number 3 says, a person attempts to pull a 50-kilogram object with a force of 15 newtons. The object doesn't budge. What is the work performed on the box? All right, so again, we are looking for work. So we need the work formula. So work equals force times distance. All right, so what is our force unit? Well, it says with the force of 15 newtons. So it says 15 newtons. Now, what is our distance unit? Well, it says the object didn't budge. So there is no distance, so that would be 0. And that means that it was 0 joules. 0 joules, which means there was no work. Nothing happened. It didn't move. So there's no work on it. That was kind of a trick question. All right, so number 4. A crane lifts an 8,000 Newton beam 75 meters to the top of the building in 30 seconds. So how much power does the crane use? Well, can we go straight to the power formula? No, we cannot, because we need work, and work has not been given in this problem. So we have to actually solve for work first, then power second. So again, work equals force times distance. So our force number would be a number that has newtons behind it. So that would be 8,000. So 8,000 newtons. And then our distance. So we need a distance unit. So that would be 75. So we have our force and our distance. So we multiply them together, and you should get 600,000 joules. So now that we have our work number, we can then now find power. So power equals work divided by time. Did it give a time in the problem? It did. It said 30 seconds. So you take your work number, which was 600,000 joules, and divide it by 30 seconds, and you should get 20,000 watts. Okay, so what I would like you to do now is to use this practice on your assessment for today.